Tas ir minimālais skaits. Un tajā brīdī tas ir tev vajag. Tā, ka
Fifth 3D printing meetup in Riga. This meetup is called Printsmas for Christmas. It's a Charles Sunday actually. So we should print out something for Christmas present. The main idea was such a combination, right?
Offering something to people. Send it out.
Okay. So those who don't know me, my name is Rihards Gailums. You can find me in social media. Here's my Twitter handle, my email. So just Google me if you want to find me out and contact me. Today's agenda. So we already had this nice workshop session before. We will have those printers after presentation part. So you are welcome to join 3D printing lab after the speakers part, right, Charles? Okay, so I start from the beginning about featured events and news. The couple of guys have visited Euromall, which is the largest 3D printing fair in Europe. So we will have a short slide combination from this event. And then we have a first speaker, Mikus, Upmalis, who will talk about for 5x5 timer. What is it, by the way, 5x5 timer? Mikus?
It's similar to similar thing to multiply printer.
It's the smallest integrated circuit.
Okay.
Integrated circuit, the smallest, like the basic type.
It's
most popular.
It's like hello world for electronics.
Yes, basically.
Yeah, a little bit handicapped on that and lame, but okay, I'll try to improve my knowledge on that. So next speaker today is Michael. That's the right name?
Fine.
Yeah, from Stratasys, and he will share about latest news from one of the largest 3D printer producers. And last speaker is Reinis from Smart Engineering about 3D printing, 3D data printing, gathering and processing. Then we should have some 3D printing startup pitch. At today's event, we really don't have any startups at all. But I would like to encourage you and find if you know some kind of 3D printing startups from Latvia, please bring them to this event because we changed a little bit scope of this meetup group, and by our initiative we would like to invite not only 3D printing enthusiasts but also 3D printing industry investors for next time. So those who have some kind of startup and would like to present, please prepare a short pitch, and we'll be glad to have you because it's the latest time for our economies to turn our vision from technology consumption to technology creation. So I hope we have more and more startups who is creating some kind of 3D stuff. Then we have an announcement part, so everybody from you could launch, could feel free and speak out about jobs, offers, and I don't know, news from who might be interested for everybody. And from the events part, so we as organizers of this technology and entrepreneurship meetups have grown a little bit bigger. We have 8 meetup groups now. So we call this Latvia Technology Entrepreneurship Meetup Network, and 3D printing meetup is just part in one of the 8 meetups. So this is the schedule for December. As you see, the first December event is here, is this one, and the next one will be held in all other events held in the Mill, which is co-working space downtown Riga, on Brīvības and Zinovs Street corner. So names for meetups such Bitcoin meetup, and we get the kickoff with biotechnology meetup in the 10th of December. We have quite big UI UX December meetup group, so we're around 100 designers there. So if you're interested in UI UX stuff, please come and see the enthusiasts. And then we have first drone kickoff meetup in 16th of December. So we're expecting our superstars, Airdog and other stuff, and other companies to appear here. So Latvia is becoming some sort of flying drone and flying objects country, something like that. And then we have first the mobile application kickoff meetup for those who are developing mobile apps. And find your co-founder meetup in 18th for those who have some kind of idea looking for co-founder to establish a startup or investments or something like that. And last one in December, we have December CUDA meetup for parallel processing and computer vision and other cool stuff. Next events for 3D printing, we got already scheduled next 2 events for January and February. It's you could find them either in this address here. I will put this presentation somewhere in the network so you can find it. This is a link for calendar for all kind of stuff, all kind of meetups we are organizing, and those 2 meetups already mentioned there. But you could find them in meetup.com, and yeah, and just probably if you subscribe to our meetup group, you will just receive a reminder of that. If you have some kind of interesting speakers or would like to speak yourself, just drop me an email. And we get a couple of speakers already for January, but probably for February we have some spots for interesting speakers. So get me know. So about sponsors, so I'm representing Riga Dec University, which is a project aiming to develop technology entrepreneurship education system here in Latvia. We get a new sponsor for all groups, it's Microsoft. So this is this actually is real support for startups. So if you are group member of if you're a member of our meetup group and you have startups, so you can apply for this Microsoft BizSpark project, not project but program, and you will get free license, I think, for every Microsoft project product they have, and you have $120 per month in Microsoft Cloud free of charge. So if you would like to register your startup, just drop me an email so I could make for your account and move forward to Microsoft. And our largest supporter in financial terms is Latvia's Gailums, who is they are responsible for developing this Latvian technology startup ecosystem in different financial ways. We get a couple of supporters. So one of the largest ones is the Latvian startup who is a producer of printers. So everybody of you probably don't know them. And we get a couple of printers, but the largest part of them downstairs. And we get FabLab guys here, who is also supporting this meeting in different kinds of information and encouraging speakers. And we got our RHTU Design Factory, so Charles, probably for those who don't know what it really is, just a couple of words. What is it? This is a place where
So I think the first thing of RHTU Design Factory is what we call the hub. I mean, we're here to do this. Just welcome you, come here. If we can support, if you can help in any way, we're here. At the moment, it's aimed mainly at RHTU students, and we aim to expand to other universities in the future. And this is what we're doing now with the lab, kind of offering possibilities to students to work with 3D printers, touching material, providing with a bit of support, design consultancy, or orientating them to the proper person. You need a 20-ton press, we give you the phone number, we call the person and try to arrange it for you. The design factory is the bigger project where the space is located right behind this wall. You can access it through that door. It's empty at the moment. It's 300 square meters where we aim to host interdisciplinary learning program. We're not doing teaching, but learning. We're giving frontally the information, but more giving you the tools so you can go fetch the information. How do you teach people? How do you train people for jobs that don't yet exist? Is one of the questions in the center of what we're doing. We're kind of getting people from different disciplinary together on product development projects. Is the main activity that is going to happen here, besides supporting the university as a whole in different approaches. I think this is it. If you have more questions, you can come either to me or to Untis, because it's also the only structure in the university that we know of with 2 heads and porcelain cups.
So yeah, it's a very brave project here, which is like I would like to point out is to trying to turn a little bit this higher educational system here in Latvia. So good luck for your project, and I hope you will succeed in that. And what is the date for opening the premise? You have some expectation?
We don't have all official open date now.
But you're expecting
but
around?
we're expecting to open it, if everything goes according to plan, end of June.
End of June. Okay. In future news, so there's a Euromod last week.
Last week.
Yeah. So probably guys from Latvia who visit this nice event probably will have a little insight in that. So, the floor is yours.
Hi guys, I'm Kristes. So I will talk about us in Euromod, not Euromod in generally. I will leave that to Giannis, because I was busy representing our own 3D printers there. It was our set goal at the beginning of the year. Since January, we've been working to be participating here. So it was our main goal to finish the 3D printer for European market. And in short, it was a success. A lot of people were interested in 3D printers. A lot of nice comments, but still a lot to learn about our own product, about the industry, about what people really want in this kind of market, 3D printers. But yeah, this is our booth. I'm really proud of it. That's why I'm here telling you that. Maybe I can ask Jan to tell a little bit more about Euromod in general, because he was running around and
Right now, or
yeah, you can.
You can.
Because all I saw was a huge hall with Chinese mold makers, because I had to walk through there.
So the place is huge. First of all, so you have 3 halls. One of them is completely dedicated to the 3D printing. The second one is the Asia mold, which is basically a place where you skip through to get to the 8th hall, which is meant for industrial uses. I mean, Guntis was there last year. You should remember how it was. So this year, especially, the organizers of the event, they tried to show more the world where you can additive manufacturing and subtractive manufacturing be used specifically in mold making and in metal working and all that. So there was a lot to see in that regard. Our own Stratasys, for example, had 3 booths in this Euromold exhibition. They were very eager to show everything they can do, and they made a great spectacle. I guess Michael can say a bit more about that. There was very many metal printing companies over there. I think organizers made a focus on that, so that you get everything starting from powder producers who produce metal powders, and ending with companies that use hundreds and hundreds of metal printers every year. So that was interesting. That one of the most interesting things for me was to visit the Hoelz conference, where I got to learn more about metal additive manufacturing. I got to learn more about what the big companies of the world are doing with metal printing. For example, Boeing, Airbus, General Electric. So what are their goals into the future? And I think any estimate of what the industry as such is going to be in the next 3-4 years is probably shooting a little low, especially seeing by the amount of materials being purchased and the amount of printers being purchased and the amount of business that's going to go on in 2015. I think the industry is probably going to be a bit higher up there. For example, Airbus is actually planning to print 30 tons of metal parts a month. That requires 100 metal printers to be set up in a facility where you have roughly 40 to 60 hours print times for a single print job. So that means a lot of work, a lot of investments, and a lot of growth for the industry. Also, I got to see a lot of new printers. I mean, Stratasys came out with 2 new printers, 3 new printers, 4? 11. I'm sorry. I should know this. There was EOS came out with a new printer. There was HP who actually said something about the new printers on the Wallace conference, and I got to see the parts. And HP is planning to get into market on 2016. So we'll see where that goes. And I think more or less that's it. Christers can finish up with this, and if you have any questions about it, don't hesitate to approach me, and we can speak in more detail about the conferences at the wall, and maybe if you have any specific questions, I can try to answer them as well. Thanks.
Well, what I thought about the Euromold previous years was that there were a lot of small manufacturers like Makerbot represented there, and I don't know, maybe it was because I was such a new guy to this 3D printing market, but this year it was more of big players like Stratasys or 3D Systems showing off what they have, and people were actually kind of going there to see them instead of all the smaller 3D printers. Little advantages that we had because we were participating there this year was because, or advantage was that a lot of these players from desktop 3D printers were doing such a poor job, so it made us look better. That's good. A lot of work now after Euromold, so don't ask too many questions. Thanks.
What was the coolest thing in
Mass portal.
What was the coolest, the newest, and yeah?
I think
Except
I
Makerbot.
cannot answer this question sitting between these two gentlemen.
But some extraordinary or standing out, some technology or I don't know, something.
I think the cool thing was the how big the exhibition has gone, right? So I remember the first time I was visiting it, you turn every corner and your, so to say, your mind is blown about what can be done with 3D printing. Then after working a year with 3D printing and coming back to the exhibition, you still get the same feeling. You still get your mind blown at one or the other corner. The coolest thing was certainly Stratasys booth. That's for sure. I loved it because, I mean, the main one, and then I tell you why, it's not only because I represent them, but in application-wise. So you can walk up to any booth and then you can ask them what you can do with your printers, and they will show you very shiny samples, and they will show the best that the printer can do. While in the Stratasys booth, you actually get to see applications, and they had customer stories displayed on 8 different sections on the main booth, and you can walk up and actually learn about how much the company saved by employing additive manufacturing in the processes, and then you can actually see the parts which replaced or helped or in some way benefited the company and how to get there. So you walk up, for example, this one place, and you see how a car maker actually made an air duct for the motor using Stratasys technology, and you can see how much they saved with using this technology, plus the benefits that they gained from there. And this was a really targeted and a really good approach. I don't know what were the results of this, but I think, as far as I heard, the results of in terms of sales was much higher than last year.
Okay, and for next year, what will be the Euromold time and place for those who would like to visit this? It's
The-
next December.
It's not going to happen in Frankfurt anymore, is it?
Yeah,
Gonna be
so the next
Düsseldorf?
show, the show will move to Düsseldorf from Frankfurt, and will move from the time frame last week November, first week December, to somewhere in end of October.
Okay.
So a month earlier,
So
and in
save your date for next year's end of November in Düsseldorf. Okay. I would like to speak here in this part of the presentation, which every meet is showing feature 3D startup from Latvia. Actually, I don't have the 3D startup from 3D printing startup from Latvia now, so I hope the next time we'll have. But I have a very inspiring story, which is actually published today in VentureBeat, that another Latvian startup called Infographics is rising. Despite a success story, the guys raised 3 million in venture capital until now, but they acquired Brazilian-based blog, or largest blog in infographics, and the acquisition sum is measured in 6 figures. So it's first time a Latvian startup buying Brazilian startups. So it's kind of interesting for me, and it's rising a little bit higher expectation of how large can grow local small country startups. So it's just for inspiration for those who would like to start entrepreneurship here in the country. So yeah, we could proceed with speakers, and our first speaker is Mikus. So yeah, please, floor is yours. So presentation now.
So hello everyone, my name is Mikus Hoelz, and today I'm going to speak about my adventures through the world of 3D printing and how I got into it. So I'm an 18 years old high school student at Riga Dec Gymnasium #1. Not only that, I'm also a co-teacher at school's Robotics club, together with Jan Zahrans, who's also here today. And so I'm pretty sure I can call myself a 3D printer enthusiast / builder, because I have built Robotics Prusa iteration 2. And I'm also working on a new printer. And besides that, I also love windsurfing and snowboarding. So from the beginning. In 2009, I passed the entrance exams for the Riga Dec Gymnasium #1. And this was my first huge leap in terms of my life. So, and soon after the 1st September, I noticed a school poster that was on the notice board about a school's robotics club. And so I thought I should give it a go and see what's going on there, and I started attending these lessons, and so I learned some new stuff and things, and I built a 3D printer. Well, it sounds easy, right? Well, I skipped some steps in there between, so I'm going to explain those right now. So, what's our school's robotics club? Actually, these two guys you're seeing here is probably the main reason why I'm standing right here now. And one of them is Jan Zahrans, he's here right now, so. And they're twins, Jans and Erik Zahrans, who founded the Robotics Club in 2007. And while still being students at the same school. And the problem they faced was that they couldn't find enough places where you can study basic electrical engineering and manufacturing of the boards and everything else connected to the electronics. So, and the places they did found was in a very low level, and they already knew more than that. And so to give like a kickstart for other students and to help get into the scene of electronics and building different devices, they realized that they can make like electronical classes in school. And so I started attending these lessons, and during the first year I learned the basics of electronics and manufacturing process of the PCBs and the etching from scratch, like and drawing the PCBs and everything else. And during this time I built my first multi-vibrator and the 555 timer that we previously got asked about. And most electricians know what was that. And but the problem was that we started the club with literally no equipment, and so all the equipment we need to bring our own equipment or either buy one, like for example soldering irons and multimeters, and not everyone had the money or to buy one or either to get one, and so the learning process was pretty slow as we had to share the equipment, and during the first year I only managed to do these things, but everything changed when in 2010 an organization called Labie Darbi helped us out, and well, it was a voting contest, but we managed to get the funding, and that enabled us to buy our own equipment, such as soldering irons, multimeters, development boards, and other tools such as saw, drill, and everything else needed. And that really helped us motivate both the teachers and the students. And because of this, we managed to raise our level of the learning process. And during lifespan of 1 year, we managed to also build our first robots. Please bear with me. I'm a little sick, so sorry about that. And yeah, during the second year, I built my first mini Sumo robot. It looks pretty bad, but there were worse cases. And yeah, so during this time, I learned a lot of new things. I learned how to program, and I started to feeling more comfortable in the electronics scene. So the third year, there wasn't much going on, but our team from the Robotics Club managed to participate in an event called Technical Youth Days. I think it's organized by Riga Dec University, or at least the Robotics workshop. And during this event, you have to build a mini Sumo in 1 day within the team. And yeah, including me, together with the team, we won the competition. So that's that. But in spring 2012, I found out about 3D printers. This was literally my face expression when I first saw the word 3D printer. And the next 2 or 3, or even, I don't know how much time was it, around a week I spent all the nights searching and reading everything I could find about 3D printers. How the technology worked, the different technologies you can use on 3D printing. And then I found out also about the RepRap, which is an open source 3D printer. And also stumbled upon this. This is a thread that was written in our local Latvian forums, Boot.lv, where a guy who goes under the name Fest documented his build of a RepRap, Mendel. And the next thing I remember, I was starting to order parts for my first 3D printer. And so this basically, I chose to build the Prusa Mendel i2, which was the most popular model at that time. So also I chose to build a 3D printer because I wanted to challenge myself whether I can use the skills I learned at the robotics lessons to actually build something useful. And so my thought process behind ordering these parts was, the less money I have to spend, the better, right? Well, I learned that that wasn't the case afterwards. So this was my initial parts that I bought from eBay or other sources. And just as everyone else, I bought some motors. I just used ones, but they worked fine. I bought some parts that have been printed on other RepRaps. They were pretty low quality, broken, but well, they worked somehow. And I also ordered some belts and some brake pulleys. So, but the things the way these two things, the electronics and hot end, was the things that usually most people would choose a different way. For the electronics, I chose to actually solder and build the electronics by myself. As I calculated, that saved me around the third of the price of ready electronics at that time. By the way, everyone who has built a 3D printer, like an open source RepRap, will know that at that time prices were higher than now. And yeah, as a student, I didn't have much money to spend, so I tried to get every lowest price possible. And for the hot end, I consulted my father, who has actually been working in machining and steel industry for quite a while now, and he said, well, he looked at the designs of the hot ends and said, well, it shouldn't be that hard to make one. So we scrapped together some plastics, thermal plastics, and a nozzle from a gas cutter. And at first, it worked okay. The problem was that there were a lot of small details and things that we didn't know about, especially in the 3D printing process. And yeah, the hot end failed pretty fast. So after that, I went to and bought a J-head, which some of you may know, which is one of the most popular ones these days for rep wraps. And also, the printed pulleys also failed pretty fast. So I went and bought some machine pulleys. So that was a pretty good upgrade for my machine. And these were first prints of with my DIY hot end. They were okay, but the quality wasn't that good, and soon after the hot end failed. And after 3 months of no work done, I finally received the J-head, and I was actually pleased with the quality I got. So, yeah, what else is to print there? But yeah, the quality actually was, compared to what I had seen on the internet from different other RepRap users, was really great, which really satisfied my needs. So, and so I had built a 3D printer. Well, what to do next, you may ask. And before I go further on, I want to go back to the Robotics Club. And in 2012, Jans and Eriks joined exchange program to study in Sweden. And they didn't want to neglect the Robotics Club and abandon it, so it doesn't. So there's nothing worked on there because we had all the equipment and everything. So they contacted some of the previous students, as I like to say, like one of the most successful students, who was studying physics baccalaureate at that time. Also, he's studying right now, and we took over the lead to study the robotics classes for a year. And next, I want to speak about how development of a 3D printer helped us in our robotics club. So before we had a 3D printer available, we used all sorts of materials to build our frames for the mini Sumo robots. Mostly it consisted of cardboard, hot glue, and duct tape. The high end was using PCBs or some other metal structures, but that was the rare case. And so yeah, and that took a long time to build, like really like a month or two, and it was really slow and painful process. But then after we got a 3D printer available, we designed. This is our first iteration, by the way. We're planning to build a new one next year. So we basically built these robots, well, at least the frames, in 2 days. And we even casted the tires in the 3D printed mold. So that was a huge leap for the robotics club in our school, and that enabled us to build much faster and higher quality robots. So for the students to be able to use. So back to my personal experience. So it was time for my 11th grade science research paper, which you have to do, I think nowadays obligatory. Well, there are some exceptions, but so I wanted to do something in computer science section, but I also wanted to somehow connect it to the 3D printer I had built, so I can use the opportunity to use it. And I chose to compare one of the most important, well, at least for the RepRap community, one of the most important things that affect your printing quality. It was the slicers. And I chose the two most popular ones at the time, and yeah, I went on and compared them. Bear in mind, those who had used any of these softwares and have any experience like in 3D printing, take this with a bit of pinch of salt, because there's a lot of missing that you can't, I didn't have time or like place to fit the information in this research paper, because it's limited to 30 pages and I couldn't fit anything more. So I compared different settings and profiles, how they worked on my machine. Bear in mind that my machine was calibrated mostly for the slicer, just as a side note. And I did also compared the speed, the slicing speed for different kind of, different complexity models, and also compared the overall object quality and different sorts of other aspects. But was it any worth? Yes and no. I placed first in Riga Science research paper contest. I was also moved to the state contest, but I didn't get anything there. Then I also participated in Receba's organized conference, which is Changing World in search of new solutions, and I got first place there too. So, any conclusions? Well, as I had known before, there were far more, many factors than just the slicer that affect the printing quality. But the paper I made gave a really nice overview of the features and the settings you can use in both slicers. So, we're back to the present. I'm currently starting a student company in cooperation with Junior Achievement Latvia. So this is not a real company, it's sort of an educational company. And I'm planning to offer 3D printing services for the low quality, and not comparing it to Stratasys, that's nothing. But it gives a pretty good idea of what you can expect from 3D printing, and use it to build some fun stuff. So, for example, it's cookie cutters. And so yeah, I'm also in the process of building a more stable printer, and which is a P3 steel. I'll show a picture later. And also we're trying to start teaching CAD in our robotics lessons to make use of the 3D printing technology we have available here. So yeah, this is the company I'm trying to make. So yeah, and this is the current printer that's in development state. Well, this, as some of you may know, is an iteration of Prusa i3. It's a P3 steel made from steel construction. It's a lot more stable construction comparing to the printer I have right now, which is holding on with boogers and everything else, and it's falling apart, but it's still printing. Hey, yeah. So what do we have in the future? Well, as you may know, 3D printing is here for good, and it's not going away anywhere soon. And it's just a matter of time when we get our personal 3D printers in our homes as a standard appliance for average consumer, I think. And yeah, and there's some famous quotes as a good way to end the presentation. And thank you very much for your attention. If you have any questions, feel free to ask, and may the 3D printing be with you.
So, any questions? Please.
Okay.
No questions?
Yeah.
There's a question. How long it takes to make?
The first printer, starting from the day I ordered first parts to the day I got my first print, it took me about 217 days. But bear in mind, it was a slow and painful process, especially with the electronics that I had decided to solder myself. I burned first the microcontroller, so that was a problem, and there's some hiccups in between there. So it's a steep learning curve, but you'll get there eventually. So yeah. Also, I have a friend of mine who also thought that he could build a 3D printer. He worked with parts last year. Well, he hasn't made much further than the frame because he has some problems and he don't want to solve them, and he wants me to solve them, but I'm not giving up that easily. So so yeah.
Any more questions? No questions?
What was the biggest challenge?
Biggest challenge? Biggest challenge. Well, altogether, biggest challenge for me was to actually learn the things that is especially connected with 3D printing. I spent a lot of time in RepRap IRC, talking with people and trying to debug the problems I had, and that was a really slow and painful process. But by now I have solved most of the problems, and I know most of the usual hiccups with the RepRap printers. So, but the debugging process is the most painful, I think.
And what was the funniest thing during the building?
During the building, I can't remember any funny moments, but there was because it wasn't really funny. But the funny part was actually I had a video somewhere on the internet where I recorded my first. It was my second thing I printed. It was the date when I first printed the first part, and it was a date with dots that I later glued onto the wall so I can remember the date. But the funny thing was that I was recording this process of printing, and one of the dots apparently hadn't stick to the bed, and just as the print was finishing, I realized that something is wrong, and during the recording I didn't even notice. I said like, what the hell is that? I was like, and I sent this video to my friend, and I hadn't noticed that I had said this thing, and he was like, oh yeah, you swear it or something like that. I was like, oh yeah, really? What? So that was a funny thing, yeah.
So now here my question about education. You mentioned the first gymnasium about background that you're starting passion to 3D printing. Did they have some kind of educational courses in 3D printing?
No, this was at the third year, as we had learned most of the stuff teachers had to offer in terms of robotics. We were able to choose like our own projects to make. Most of the people went with some smaller boring projects. There were some, I think there were some LED cubes made, but I went for a bigger one, and as you can see, the 3D printing, and this was solely my own, I learned it all by myself, and the teachers didn't, well, they had heard about the RepRaps and 3D printing, but at that time they didn't know much about it. And one of the co-teacher that I'm working with, the Zigmas, he actually, when I told about that I'm going to build a 3D printer, he came in laughing and saying that, like, no way dude, you're not gonna make it. And so yeah, here I am.
So how do you see your future path for educational? Are you going to study some this field or leaving this country, or what is your...
In educational background, I really can't decide whether to go outside the country, study and then come back, or to stay in the country and start some businesses besides the studying. So I have yet to decide. But in terms for school education, like giving back something, I have an idea of possibly making a dedicated 3D modeling classes that I could offer, but we have yet to find a 3D printer in our school and all the licenses for the software and things. So
looking for partnership with some companies probably sitting here.
Possibly yes, but I have something else in mind too. So
do you have plans just to return to the printing practice? Do you like, not exactly do you like, but if I look on your presentation, you have very good investigation on 3D printing, printing itself. Do you have plans with exact power just to return to this locally based, locally produced printing?
I won't be concentrating much more on the actual building of 3D printers, just as far as my own needs to make some 3D prints and offer the services. But I'll be definitely trying to make something in this sphere connected with 3D printing. So I'll yet to see how it turns out. I can't really answer to that question yet. So. Okay.
Okay, thank you.
Maybe here, yes? Just give me a second. Ask me. Yes.
Be careful. So, yeah, all is yours.
Stage is mine. So, my name is Mikus. Second name is Hoelz. Don't try to pronounce it, you will break the tongues, as I will with your names. I'm working as a sales manager for Stratasys, responsible for the Central and Eastern Europe, which means German border and Alaska, more or less. Well, at first, open spoken, I don't like to have a frontal speech. So whenever you have questions, simply ask. What I really like to say in the very beginning, I'm absolutely fascinated. Okay, perfect. When I'm remembering one of your first slides sitting in front of the table with all the stuff, this is about 30 years ago of Trump, who invented the Fdm technology. Doing nothing else than sitting in the kitchen with his older brother and inventing 3D printing and inventing the technology you all are using downstairs, which is the Fdm stuff. Just a 2 or 3 sentences to the Euromold show, as Janis already mentioned, or you already mentioned. It has been the biggest show ever this year. The showground or the hall has been definitely packed with other, and one of the reasons why the organizers are going to change to Düsseldorf for the next year, simply to have a bigger showrooms. I would say the theme is going into 2 directions, or actually into 3. If you look into the low end sector, we see, as mentioned, less companies producing, how should I name this politically correct, shitty stuff. Going back to 3 years, you bought a 3D printer kit, and and I would say about 75 to 80% of these 3D printed kits haven't been put together to a function printer. This has completely changed. Everything which is on the market right now, and which has been exhibited at the Euromold, has been, I would say, quite good stuff. From the very low end, I would say the cheapest printer you could get was around 800-900 euros, producing pretty good models to things like, for example, our Makerbot stuff or your printers. Well, delivering really acceptable quality in the lower end of the 3D print business. If you go more to the industry, it's clearly going into 2 directions. On the one side, the design, which is getting better and better, even more materials, the chance to get multicolors, to get combinations between rubber materials and color rubber materials, enriched materials. So to get to a really, really good product realism at the end of the day. On the other side, it's going more and more into the industry applications, like Janis mentioned, metal is getting stronger and stronger. By the way, Stratasys is the world's biggest producer of metal parts without being able to sell metal printers. Okay, it's like this. Well, industry applications are getting more and more, and this is leading me to my short presentation, which I brought with me. I just want to show you some things our customers are able to do with our technology, and I picked out especially the Fdm technology and not the PolyJet, simply because you all are working with Fdm technology down in the cellar. You know that we are using industry-grade plastics, starting from the very easy ABS plastic, ending with the Alten 9085, or now with the Alten 1010 material, which is temperature stable up to more than 210 degrees Celsius. So very, very high-end materials are available. The engineering plastics you all are aware of when you're studying any kind of engineering studies. So, well, as mentioned, we are using two different technologies. You know them all. One is Fdm, which is nothing else than melting a thermoplast and then extruding it through a very small nozzle, laying down a fine line, and then filling the entire layer with the fine filaments, and then printing layer by layer by layer. The other technology is nothing else than an inkjet printer. So we call it PolyJet, but at the end it's nothing else than your standard, I don't know, Canon or HP inkjet you have on your table, but you are not printing ink, you're printing a photopolymer, which is an acrylic plastic, which is then hardened by UV light. I'm simply flipping the inkjet technology, and openly spoken, flipping the Fdm technology as well, simply because you have it downstairs. And I would really directly like to jump into what we call DDM applications. DDM stands for Direct Digital Manufacturing. If you see these pictures, this is nothing else than sheet metal forming, which is done with printed molds, which are printed on the Fdm printer. The plastic which is used is polycarbonate plastic, and the examples we have here is this, for example, is from a customer out of the aerospace industry. It's a repair shop. They are repairing old, mainly propeller-driven planes. And this is an aluminum 2.5 to 3 millimeters aircraft-style aluminum sheet metal, which is bended over the printed form. We did about 85 of these. Then we stopped simply because we didn't, or they didn't need more of the sheet metal formings. But the mold hasn't been destroyed. If you now compare, you need to print this mold approximately 6 to 8 hours. If you go to your model shop and like to have the mold milled with a milling machine out of steel, it will need you a couple of days to get the stuff ready. Going to the top right, for example, this is not an aluminum, this is a 2 millimeters sheet metal steel. The example comes from, don't tell it to anybody, it comes from Honda. They had a problem within a crash simulation, and they noticed they had to weld in a stiffening steel part. It took us 24 hours from the detection of the problem to printing of the mold, pressing and stamping the sheet metal, and welding it into the car. Time saving, cost saving, and the ability to really weld to a crash test with a known failure which could be solved within 24 hours. This is unbelievable. This stamp just stands, I think, 3 or 4 times, then it was destroyed. But when you just need one of the stamped sheet metals, it's enough. Pressures which are used for example, this is a 4,000 pounds press. The top right, I don't know, I forgot. But it's much more simply because it's a steel. Well, things which are made and which are quite common is surrogate parts when you are starting, for example, to set up a production line for setting up robots, setting up milling machines, and so on and so on. You simply print the part which is actually later on out of cast aluminum or cast iron, and use this as a surrogate for the original part. Simply to be on the safe side by setting up the anti-robotic, not to destroy the grippers and so on and so on. You know, if you run into a contact with a milling machine or with a robot, this can cause quite expensive damages. Other things might be interesting for the robotic guys. This is composite tooling. So you're printing a core, like for example these, out of either Ultem material or ABS material, 40 carbonate material, and you are then wrapping the core with either carbon fiber or with other fiber materials to get a composite composite material which is quite stiff. Can be done quite quickly. What you can as well do, use the cores as a kind of a mold for fiber layups. Another nice thing is, this is what Janis already mentioned, one of the applications which is quite well known meanwhile in the sports car and race car business, which is called soluble cores. You know, we are using one build material and one support material in the printers. The support material is always needed when you are printing either undercuts or whatever, where you have to support an overhang. This support material is mainly soluble, so we have two different support materials which are soluble, and one is a breakaway. And what is done here is, on the high-end printers, you can tell the printer simply don't use the build material, use the support material to print. And then you print a core, you wrap around the carbon fiber, and you later on wash the core out. And then you have really complex structures for air intake, for intakes, for example, cooling ducts and so on, which are not glued together out of two or three shells, which are simply made in one part. Other applications. This is packaging industry, thermoforming. You know that the Fdm printed parts are not airtight, neither airtight nor watertight, which is a big advantage for this technology. You simply print the mold and put it through the machine. This is a hand-driven machine that you can also use the cores on the big industry machines. Well, print time of the cores is rather quick. This is really another example for time saving, cost saving. Quite simple things like assembly tools out of the automotive industry, things like any kind of complex shapes which are helping in the production. Then when we go to end-use parts, and here we are quite often using things like nylon or like the Ultem materials. Then you have even in planes things like these, which are printed and then used. And even if you sit in an Airbus, you will find much more printed parts in an Airbus than you would think, especially things which are in the cabin but not cosmetic. So everything which is behind the passenger-facing plastic, things like air ducts, things like cable clamps, and so on are printed with the Photos printers. This is why we are using the Ultem 9085 material, which is aircraft tested, so flame and toxic, and which you see here, for example. Not that interesting, but what could be interesting for you is this. This is an unmanned vehicle which is printed, and just only printed. We are able, as you can see here, to print hollow parts, completely hollow inside, simply because we are using a 45 degrees self-supporting angle. And the planes are really, really light. They are perfect in flying. We can do at least everything with them, but we can't land them. So this was after our first flight. During the landing we hit a truck and, well, that's the result. If anybody of you is interested, I can provide the STL data of these planes, which can be printed on an FDM printer. Point is, you will definitely need one of the big photos machines to process at first the right plastic and to get to the part size. It's glued together out of one, two, three, four. So the wings are 4 parts. The body are, I think, 5 or 6 parts which are glued together. But if anybody is interested, I can provide the STL data. So that's it from my side in regards to the industry applications. Questions? At least ask everything you want. What I'd like to show you is the following. There is one very little movie I'd like to show you, which is an FDM printed part. Go on. Hello.
Do you have an internet there? Oh.
No.
We know you.
Not a problem. This is a nice example. This is an Altem printed part. It's about the size of a cigarette package. The weight of the part is 26 grams. This is our Fortus 400 printer. The weight of the printer is a little bit more than the one of my colleague, which is right next. So the printer is about 600 kilos.
Good.
I have a question. Why did the planes break?
Why did the blade
Yes.
break? Well, quite simple. Quite simple. When you are in the landing and when you are hitting a truck.
Okay. The truck is stronger.
So.
As time is going to build up the printers like for food or for building, like in constructions.
Yeah.
So do you have the ideas to build up the printers for that kind of applications, like print the food?
No, definitely not.
That.
Definitely not. So all these things you see, for example, Barilla printing noodles, or some bakeries printing chocolate cookies, or and so on and so on. This is simply made out of the DIY sector. You have a printer which you can feed with at least everything. And going into the construction business, so printing at least complete houses with an kind of an FDM printer is possible as well. You simply need a printer which is big enough, and the software.
Yeah.
But the results are quite poor. So the construction work is quite poor, and the noodles as well.
Returning to planes,
Yeah.
in that image you had some, I think there was 3 planes.
Yeah.
What happened with the more planes? Did they land okay, or?
I don't know. I don't know. It's just the picture from the first flight we did, where my colleague Amos hit the truck. Okay. Please. Okay.
I have a question. Why does Stratasys work for Fdm printers when PolyJet and other types has better results?
Well, Fdm is one of our technologies, and PolyJet is one of our technologies as well. And third technology we have is called, it's a wax technology you will find in dentistry and in jewelry for wax cores. So this is mainly what we're doing right now.
So, any more questions?
What was the strategy behind acquiring Makerbot Industries?
Well, strategy behind acquiring Makerbot is quite simple. We did not acquire a new technology simply because it's our technology, but we acquired the entire ecosystem behind Makerbot. So the databases, I forgot the database where you can download Thingiverse, for example. All this makes the Makerbot. The machines or the technology, this is not interesting at all, but the community behind all this is interesting.
Why Makerbot industry is like a very shady, controversial thing? If you read all about, Stratasys always are pioneers, very stable, commercial thing. It's like rock. But when you look to Makerbot, it jumps to one side, like open source. Oh yeah, we are the main, most open.
Yeah.
After half year, it's like, no, we always were like, okay, it's very strong commercial thing, no open source at all. Then there is Thingiverse, which is perfect platform, but again, after half year, they said, listen, we have a licensing thing and all your stuff actually is ours and it's our IDs, what grow inside our page.
Okay.
It's like controversial thing, but
No,
your politics are completely different.
It is not. So, at first, our companies are not completely different. We are one company. So, Makerbot is Stratasys. Makerbot is keeping the old name, yes. But Makerbot has been acquired about a year ago, a little bit more. Makerbot started really as a startup using the Fdm technology, which were the patents have run out. So everybody is allowed to use the core patents from Stratasys. This is the reason why the entire maker scene is growing and growing and growing. It's a technology which is quite easy to handle. If you're keen in printing in building your own printer. It goes to the more advanced applications. It's a little bit more behind than just putting together some. So they started as an open source with the Makerbot printers, with their software, with the Thingiverse as well. But once they have been acquired from us, they had to provide some money. We have to earn money at the end of the day. And this is the tragedy behind most of the startups in the open source. When the Kickstarter money is exhausted, many of the companies are simply disappearing. So there is no business model behind, or no working business model.
There is Printerbot and Ultimaker.
Yeah.
All three companies started exactly the same way.
Yeah. Well, for the Makerbot we need. And if you look into the Makerbot products, there is more and more intellectual property from Stratasys going into the Makerbot products. And
just molded all patents together for.
Did Makerbot have any patent?
Yes.
for sure.
Okay.
For sure, in all the other years.
And there was some, quite controversial patent which was placed in and actually there was no one who actually created them and much earlier before they said that it is their discovery, their patent.
I'm not sure if I got the question right.
No, I just loudly.
Okay. Good. Further questions?
In few words, could you say about history of Stratasys, how the company is created, then where's your headquarters now?
Yeah. So, as mentioned, the company is about 30 years old meanwhile.
Okay.
We have two headquarters due to the fact that we merged with Objects about 2.5 years ago. We have one headquarter which is in Minnesota, which is the headquarter which is responsible for the Fdm Technology, and the other headquarter is in Rehoboth, which is Tel Aviv in Israel, which is responsible for the PolyJet technology, so the form of Object.
So in general, Stratasys is an American company.
In general, Stratasys is an American company with a almost 100% Israel management.
Okay.
Almost 100.
But the story is quite simple. Everybody who looks into our books will see how it comes. If you merge two companies, one company is public since about 30 years. You have the shares in the hands of a couple of thousand investors, and the other company has, so the one has 51% and the other company has 49%, but in the hands of actually two investors. And then you know who is setting the course.
Okay, but in the very, very beginning, there's some genius founder of this company in American part or in the Israeli part?
Both. So as we have two technologies, so the history behind the Fdm technology, the founder is Scott Crump. The initial idea, his brother invented a system which was a kind of measurement tool. So you have a ready-made tool out of the casting, either metal casting or injection mold casting. You have a ready-made piece of I don't know what, and you like to test if this is really the result you have constructed on your PC. Then he invented a machine which simply skimmed away layer by layer and created a cloud out of dots. So you skim.
Late 80s, last century, something like that.
The 1980s, yeah.
Okay.
Mid 80s. So Scott's brother created a cloud out of dots, and and the other idea was, okay, if we are able to create these dots and this was years before we had good computers. This was years before we had any CAD systems or anything. So then the next idea was, okay, we have these cloud of dots and we can construct something in the IT. What can I do with that? And is it possible to create an object out of these dots I have? And this was the initial idea. And then they started with trying to extrude the first wax, which didn't work that well, and tried different combinations out of wax and plastics, and ended up later on with ABS and so on and so on. Mm-hmm. And the idea is commercialized since 1989, where we sold the first printers. And the other technology, Object, is a startup which came out of the company Cytex, which has been acquired by HP. Cytex is manufacturing ultra-wide printers. And after acquiring the company, being acquired by HP, some of the engineers left, and they started with what they had with a 2D printer, and started to print with the liquid plastic. I've seen the first results they did in one of our showcases, looking more or less the same like what you did with your printer. So some plastic was there, and then after, I don't know, 2 or 3 years, they have been able to print reliable results.
Okay, so it's quite amazing that in the late 80s there was created first 3D printing machine, something like that. Is that computer?
So the first machines came in the middle or late 80s. At first it is stereolithography, and then FDM.
It's quite old technology.
It is quite old, yes.
So probably last question for Michael. Is there any? No questions. Thank you. So I get all those pictures. So any floor is yours.
So, hello boys and only lady here who's just met. My name is Reinis Tocelovskis and I'm Executive and Sales Director of holding company Smart Engineering. And today I will tell you about the service our company is providing in Baltic states. We have different kinds of businesses, and one of that is 3D data getting and processing. So before to go to the printing, you need a 3D model. So that's what we are doing. So we are one of the biggest company in Baltic states who's providing the 3D scanning service, and at the same time we are also official distributors of a bunch of 3D laser scanner companies like Creaform, Surphizer, Artec, Faro. So actually they are the biggest ones and most serious companies worldwide. Today I don't have like a presentation for you, but I think so I will just tell you and show you some examples what we are doing and what kind of data you can get and how you can process the data to manage any kind of situations probably you will face in your professional life. So, the first of all, oh no, that's not what I want to show you. Okay, our company can do, let's say, almost anything in 3D modeling and 3D data getting, starting from the smallest parts and ending with the complete cities and airborne scanning and big area 3D modeling. Let me show you one quite difficult example. So this is one part of the car. So we made a scanning of this part, and after this we can produce even till old drawings in 2D and give you the old data you can use in any way, also 3D printing. So that's what we can offer in for 3D printing, but also there's many applications. Normally we are working very less for applications like when you are after the data going to print or use for 3D printing. But however, I will show you then some options. So the process is oh yeah, there it is. So let's say you have some real part, and you wanna let's say print this part, or before printing do some change, add something or change the schedule, whatever it is, so we can print it, so we can scan it. That's how it looks 3D file and model after scanning. So the quality is, the best quality you can reach is like up to 50 microns, and it's really quite good. The second option normally are using the factories is using the software Geomagic Verify, we can see the difference in real 3D model or your project and the part you after made. Like this is one part. There's a company in Latvia who is flying in these flying tunnels called Rodium, and this is one part of the turbine. So we scan this part. It looks like this. Then we got from the client project, and what we can do, we can put these two parts together and see any. Sorry, that's a good
Missing of material.
yeah. So whatever it is, so any differences between them.
Intolerances.
Yeah. So it looks like this. So we have US scale, and all what you can see in red is what you have to take away. And if there will be something in blue color, then you can know that this is a defect, and you have to analyze this. And like here, we can see that there is really missing something. There is no material to take away. And here we can see that there is a big problem, and it looks on the screen like this. Then in the gray, this is a 3D model, like it should be, but in the blue color you can see the real part, and one angle of that is really too much not in that place. So the client can take the support and go to the manufacturer and tell him that sorry, but you have to do it again. That's what we really are doing in Baltics, one of the things. Then of course there's a bunch of things that you can do in application for the building constructions, and scan also huge objects after do the modeling and give to the client all amounts, how much square meters there's windows or walls that they can put in the tender, and they can be sure that the construction company is not, let's say, not cheating and putting extra amounts, which cost a lot. And especially in the Baltics, the situation in construction is that building companies, they're winning the tenders with the low price, and after trying to get their money back in extra work. So we are, they don't like us. When we are going to the building construction, they really are afraid from us, because we always see what's wrong in the object. And yeah, so that's also one of the applications. Of course, then there's also some interesting things you can do with the laser scanning is you can scan the places which normally is not accessible, like you can see in the building there's a corner, and we can get from the laser scanning all the parts, and for the engineers or the guys who are going to do the renovation, it's very easy to get all data from the laser scanning. So then of course in Geomagic Verify, I'm thinking about 3D printing. What you can do is, first of all, if you have a 3D model, you can compare the real printed part with your 3D model, and see what is the difference and how your 3D printing works, especially for someone who's like building up their own 3D printers and stuff like that. So and with accuracy like, let's say 50 microns, and it's really good measurements. Or yeah, so if you have some parts, actually this is really good for Chinese, who's always stealing anything from anyone. So if you want to, let's say, build up this mouse, then you can just scan it in our office, and we can give you the exact 3D model, and after this you can change it or not change, and print the same mouse and do all the next things you want. Yeah, so just, I don't know what else to tell about the 3D scanning. So I think so the main thing is that now you know that here is the option, and especially with the universities, our company is quite open. We are always open for the students to scan something. Of course, we have our own schedule, but if we have a free time, we always can deal with that. You can come to our office, scan something, like we have some interesting projects with also the guys from Multi 3D about the protease and the arms and stuff like that. So yeah. And only a few things I want to say else is we also are developing our own flying drones. So we showed our drone in Intergeo this year in Berlin. I just want to show you, who knows, maybe some of you will have some ideas. Yeah, so this is our own drone, and it's really, actually, really impressive thing, because all technical characteristics is really high. So the first of all, it can take up more than 10 kilograms. So with the 7 kilograms payload, it can fly up to 40 minutes. Also, it has all safety system according to the newest European Union regulations. So there's 2 parachutes in emergency cases, which goes out, and especially if you have like really expensive payload, like laser scanner, who costs around like 45,000 euro. You know.
Actually, you are using for laser scanning some buildings and arms.
Yeah. So at the moment we have 2 drones, the big one and the small one. The small one is for photogrammetric solutions, so you can actually get the 3D model, or let's say 3D point cloud from photogrammetry, and the accuracy is like around 2 centimeters. It's quite good actually for many kind of applications, but the laser scanning, there's a huge market in laser scanning business. That's why we actually are, at the moment we still are developing the solution with laser scanner. There is some things we have to figure out, but I'm sure it will work next year, maybe February. Yeah, sure.
Are you also able to identify the different materials through the scanning with the laser, or is that some field you're thinking of developing?
What do you mean to define different kind of materials?
You're scanning a building with the laser. The laser knows, okay, this is glass, this is concrete, this is wood.
No, I didn't hear that there is some laser technologies who can do it. I don't think so. Of course, you can see like there is there's a colored point cloud. So this is a Faro technology. So when you get the point cloud in colors, actually you can very easy define which kind of material it is. Of course, it depends on your needs. Yeah? If you are talking about the drones, then there's many applications which using like special special cameras, which is really good for agricultural applications. Like you can see in which stage is your land and when you have to take away this production and stuff like that. So, but we are not the specialists on that. At the moment, let's say we are developing drones, and of course with some kind of applications, but not for a so special one. Yeah. So the last things about this drone is that there's also all maximum features you can actually get now, like automatic marshal trajectory planning, like see and avoid system, that it will not break somewhere on the cables or along the trees or stuff like that. And also like 2 ground stations which can communicate between each other. Really cool stuff. And the last thing I want to show you for today is also one of our businesses is georadar systems, ground penetrating radars that we can see also underground, and mostly it's for communication detection or some far detection underground. I'll just show you one report we read for our clients.
This is ground penetrating, what the result is? Is it some bipod?
No, it's like no. It's a radargram, so it looks really.
Disturbance, like disturbance damage.
Yeah, so I can show you how it looks, and this example will really good show how this technology works. So we have there it is. Oh yeah. So normally we can see that there is some systems. So they're doing some drilling and taking samples, and then the geologists can say that there is a sand, there is this and that, and so on. But very often in real projects, the situation is like that. So I don't know, can you see from there, but this is a radargram. And what our specialists are doing, they're using special software to see all the radargrams and then interpreting the data. But
The result, are the results in 2D, not in 3D?
not exactly. We are getting actually 3D picture, so we can see like the layers.
All cluster and layers are.
Yeah, we can go down by the layers, and then we can see like if there is a wall, then there is a wall. If there is a communication, then there is a communication.
How deep?
It depends, but normally it's like up to 6 meters. It depends on the client's need. But the report I want to show you is like really good example in construction. Yeah. So there's an area before construction starts, and so we survey that area, and then we are saying them that like there is a wall, there is a cables, there's this and that, and before to start doing anything, it's very important to know because, yeah, sometimes and actually very often it happens that if you don't know where the communications are, you can damage them and then big problem starts. So we are a solution for all this kind of.
How practically is it done? By drone or by some kind of guys going around this tripod and putting on the ground?
So we have a different kind of technique. So one of the biggest one looks like that. So we can scan the streets like.
And how quick it is? Just you drive over and that's it, or?
Let's say with that one we just drive over and like 10-15 kilometers per hour.
Quite quickly. It's
Yeah.
fast.
Yeah, it is.
And how deep it scans?
Actually depends. It depends.
Depends on speed.
Yeah. Sometimes, let's say, sometimes we can reach only 1.5 meters. Sometimes we can reach 6 meters. But if there's like situations that we have to reach, then there's a different kind of stuff we can use. It's not so easy like that, but yeah, we can do the job. Let's say up to 5 meters with the guarantee.
Let me suggest you, because I see that is one client for you in here. If you combine your drone with the radar, not with the scanner,
Okay.
then you can sell the drone to the Riga,
Okay.
and they can fly
Fly around.
in the Riga Bay and measure how thick is the ice.
Actually, it's not about radar. It's more about. I'm from radar department, but another guys in the hydrographic department who are just going with boats and measuring everything.
But you are not interested in how thick is the ice in the bay.
Actually, let's see, from radar. You could also use a niche go.
No, what we can offer for Riga Sport, I don't know, is it your, but like there's a call, so normally we are scanning the.
And you're actually doing it very often because you will not believe these guys are cheating just for 10 kilos. Each time, by then you have three changes of stuff, and they can say, okay, we will put one, it's in English, excavator comes away, for example. And you will have difference in some, kilos. It doesn't matter that you will exchange by that for 100,000 of tons, but the cheating is always in something.
Yes, you can cheat.
So if you are talking, you can do this also with laser scanning or with the drone, and there's special softwares which can really easy and fast give you the amounts of a coal or whatever it is in the import. So yeah, there is an option. So I didn't know that there is someone from Riga.
You need some concurrents that will check you. In Baltics.
Yeah, and we will pay them, but they will not tell what the
Question. Very long time ago, I have seen in Discovery Channel some documentary of you are related.
No, I don't know exactly who, which kind of laser scanners they used, but it was not the Latvian one. They were just the specialists from the RTU from Latvia who do the job there.
Okay. As I understand, there was something special in the program, something related about calculating the point cloud thing.
Yeah, you know the scientists, they always like to make simple things very different. Okay, guys. Yeah, so yeah, there's a bunch of applications, bunches of options what you can do and where we can help you. Only, there's many clients who is coming to us and we actually didn't even know that something like that is necessary, you know. That's why my task today is just give you some examples, what kind of service we can give, and then in your special needs, I think so you'll always know that, oh yeah, there was some company who can do the scanning, can do the 3D modeling, or do the scanning from the air, and do also underground scanning, and give you all the data you need. So, yeah.
You producing these drones?
Yes, these drones are our own technology.
And you're selling them?
We are selling them, yes, exactly.
What's the price of the
all your money and best shoes?
strongest?
In Riga Dec I've seen ED.
Do you build those drones by yourself?
Yes,
from
exactly. These are all
assembling from different
No,
parts?
no,
Or
no. This is manufactured here in Latvia and all made by us. I am telling about drones because I heard
Meetup and some Latvia is getting drone country, drone manufacturing country, or development.
Do you make also those laser scanners and
No.
radars?
No.
Oh.
We have only one technology designed and completely built by us is these drones. All others, we are official distributors here in Baltic States and some products.
Cooperating with Airdog or no?
No.
Not talking.
It's another
Airdog is something very small.
It's action sports market. It's not for industry.
Yeah, our drone can take this Airdog and...
Not only one, but at least 10.
Yeah.
How big is this drone in real size? Is this size or that size?
It's like mothership for Ireland.
Yeah. It's like this room or...
Let me see, maybe I have some...
40 minutes, it's very
Like
good.
in Avatar.
Oh yeah, it's a huge flying machines.
So it's like this.
It's really big. Yeah. It's
like square.
The box is 1 meter, 1 meter and 70 centimeters. So you can just put it in the vehicle.
And what's the weight of the
Drone itself.
The weight of drone itself is 15 kilograms. I will just open you one small secret. Let's say next year we will have drone which can fly, I'm sure, up to 20 hours.
What kind of batteries you will use?
Nuclear technology.
Printed conductors. We are in 3D printing meeting.
They will carry someone pedaling.
3D printed batteries.
I will not answer to you on that question. Because truly speaking, I don't know. We started this project just this year. We
Flying 3D printer. You can fly and print somewhere?
It's flies and printing.
You could
Printing while it's flying.
Also print.
Print the building.
While flying from point A to point B.
Yeah.
You can print your batteries.
Then it's printing.
Last question.
I've seen a bus driving around in Riga with I think it's a 360 some kind of scanner. Is that one of yours?
Not Google.
I think it's
No, it's not the car.
If the car is with our smart engineering logo.
I have seen there is this electronic shop Argus, and
Yes.
I have seen there.
Exactly, that's our one. That's our one. So we have the 3 laser scanners with the all best navigation and inertial navigation system you can get ever, and yeah. So, stuff. Actually, all investments in all the equipment was like around 3.5 million euros. So trust me, there's the best solutions you can find in Baltic states, and I think so in closest area.
And how do you practically scanning the buildings? You should go in every room and put your equipment inside the room, or how it's done practically?
So practically, it works really similar to the total station. If someone knows how the total station works.
What is the total station?
Okay. So usually we just you're putting the laser scanner on the tripod like the video camera, then switching on, pressing the button, and it's scanning around. What it's doing, it's putting the points with the known coordinates, let's say, with the known local coordinates like X, Y, Z. And in 1 second, laser scanner is giving us up to 1 million points. So, like, we are getting billions of points of one really big building. And then what we can do is we can take this point cloud, put in the software, and actually starting from AutoCAD 2013, it allows you to import a point cloud as well. Or if you are scanning with a small scanner, it is giving us.
It's like some kind of handheld.
Yes. Yeah, exactly. So. There is all scanners, like some of the scanners we have. This is the most accurate scanner in this class in the world. That Exascan is from the company Creaform. We can scan up to with accuracy to 50 microns, so it's quite good. Artec, Faro, Spider is also some kind of technology we can use in different kind of cases. Like Artec is giving us a texture and the colors. With Exascan you can do more accurate job, but you cannot get the colors. And in some cases the colors is really necessary. So all equipment we have is we specially buy it to do any kind of job in any kind of applications, to help our clients in all possible fields.
But you need to put in every room the scanner, or you
practically
go through the walls?
No, it's not going through the walls. So it's just
you need to get around
see
from floor to floor, from room to room to get all.
It's actually just a technical issue how we are doing that.
Okay.
We're just putting some markers or squares and
okay.
Does these scanners work by themselves in Euclidean coordinates?
There's two options. We can scan in local coordinate systems. Like there's no known GPS coordinates. Static scanning, yes, it's working like just putting the scanner there, push the button and waiting when the job is done. These small scanners, they're like handheld scanners, and you have a part and you just like scan around and then get the data. And the small ones actually are giving you the files in STL format you can use in SolidWorks or any kind of software you are using for modeling and stuff like that. So it's quite easy.
Okay, we need to wrap it up. Thank you for So we get to the last part of the meetup, which is called announcements. And really Charles will be the first one because he's already asked me. So everybody who is want to print object, looking for designer, job offers, printing is service offers, event announcements, startup projects, introductions, feel free and come on and speak to all this. So Charles is probably the first one.
Okay, just a big thank you to all of you for coming here today to the first ever public event in Lab. We're really proud and happy that we hosted this 3D printing meetup and the Printsmas. Printsmas, which could never have happened without support of Mass Portal. Thank you. And well, just give you a big virtual hug.
Thank you for hosting us, and I hope that next two meetups probably also will be held here. If there's nothing will be wrong with administration of building and other stuff, so yeah, just let me know. So we will be happy to host it here. And yeah, any more announcements for 3D printing? Yeah.
This Saturday, there is happening Union Achievement Latvia annual some sort of market for the student business enterprises, and I'll be selling 3D printed cookie cutters, which are pretty awesome. And so if anyone wants to check out and support me, go ahead. And it's happening in Riga Plaza Mall, so feel free to come and check it out. So that's that.